Hello everyone, and welcome to the second session of Bonsai Lab Coding. Today we're going to cover how, sorry, there's more people coming in. We're going to cover how we load in 3D scenes into from Blender. And yeah, Gonzalo, do you want to go ahead and take over?
Yes, and actually to make it easier, I actually just uploaded, I think half an hour ago, a new version of BonVision, so can to make this bit easier. Because before, so this new functionality builds on top of a few different packages that we can talk about, and it kind of goes layer by layer until we get to BonVision, and now we can load the scenes directly there. But so I can try and show that. In fact, I think we might even have some difficulties with it, but it's fine. Let's see how, I guess, Anna. Okay, so yeah, so last time we went through how to create like a basic BonVision scene. You kind of create the window, you load the resources, and then, yeah, we kind of, I think we went through 3D. I'm not sure if we went through the 3D examples, but I think yes.
Went through one, but I think
one with the sphere, yeah. So I guess I can show just, before in BonVision, we had the support for 3D models, very simple ones that you can load with or without texture from OBJ files, which is like a very common file format that you find everywhere because it's very easy to parse. It's like a text, basically a list, a human readable list of vertices and colors and other things. Yeah, and this would so this would be like loading a plane. This is the only object that comes with BonVision, and yeah, usually you can use it as either you can put a bunch of them, so you can create. Yeah, there's no color right now, but we can create it, and then you can make like many of them, and we can kind of yeah, like move them around and so on. Yeah, have independent control of the, so you could kind of like create a little scene like this where you just move things around. But then at some point, and this is fine for like simple things, but then at some point you might want to kind of build up more complicated scenes, and then this becomes a bit tedious unless, I mean, it's fine actually, but you can also you can do this dynamically as well. So we can go through that, how you would dynamically create and position these objects. But sometimes you'd rather just draw something on an external editor. So the way that you would do in other engines like Unity and so on. Yeah.
Could add in like the demo that's on the website, which is like there's a virtual corridor demo,
yes,
which we made. And actually also in the preprint, there's a platform demo. Those were made just with these basic objects.
Yeah, exactly.
So
yeah,
just with textures, and I think we added a sphere in one of them, but that's just like taking a 3D. We downloaded a 3D model from online and put it into this.
Yeah. So you can definitely, so for example, in here, so once you create, I guess it's useful to go through just a little bit about that. So even with this, you can already do certain things. So for example, we can add textures. So that's one thing we can cover now. So you can add images to BonVision. So I'm going to pull, I think I don't know if I have anything handy, but let's pull from the internet something. So let's pull Firefox. You can just pull, I will just pull a cat image or yeah, we can use the examples. You can use the textures from the examples. That's also not a bad idea. So you can go there. You can just go to the, yeah, that's a good point. We should just go there to BonVision. And I think, so there's the examples repository. where you have like a bunch of different ones. So I can just download this. We can pull the from the demos. We can pull the corridor in VR. Good point to see if that still works. So we can put it in desktop, and then let's go to we can actually just open that example. So did I corridor VR? And see if that still works. Yeah, so we have like a 3D corridor where you can move with your mouse, and yeah, that's all done with these planes. So if you actually go inside the, so the top level is still quite simple, but you have these then these kind of sections of the corridor that you can go through, and it defines like the different walls in the corridor. And if you go inside, in a way, they're just these textured models that we were just showing that have they're just planes, they're positioned at certain angles and certain scales. And we then also, the textures that are here. So these are the walls of the corridor. They have these kind of images applied to them. They're JPEG files, and you can essentially, for each of them, you can, so that's the way you apply a texture to a textured model. So you use this operator called bind texture. You bind it to the shader textured model. You pick a texture name from the ones that are available, that the images that you dragged in, and then that model will be drawn with the surface that is mapped to the. That depends on the way the geometry of the object is also defined, but it will be we'll have the surface will be tiled with the image. Yeah, and then you can just repeat. So these are just a series of these textured models for the main room. So you have the seal, floor, right and left, and then these ones are the different sections, I think, segments of the corridor.
Gonzalo, maybe just to simplify, you can comment out all the textures.
Yep, we can just these ones.
Yeah.
And then, yeah, so that'll be just a tiled corridor, because the others are drawn on top of the, in this case, each of these is drawn on top, I guess. Or where is it? Yeah, it's there. Yeah, so these are all different objects that you can apply independently. So yeah, so you can actually do quite a lot even with just planes. Or you can use, like last time, I think we loaded a sphere, so you could do the same idea with spheres, or with other objects that you create in Blender or other tools. But as I said, so here the strategy is still with draw textured model. You would draw one model, and it's a simple model. Not even, you can't even load like a complicated scene, in the sense that if you go to a 3D modeling software, you would usually create, you can create like these complicated objects that have different materials and different colors and surfaces and so on. And those would be the texture model as it is, as it was before. You couldn't actually really represent that. And that's what we started moving towards with this new release of Bonsai and BonVision, is to add support to load more complex content. And so to do that, just as As an introduction, just as a reference here for people who will be looking later, so the library that we converged on is the Open Asset Import Library, ASIMP. So this is a very popular kind of library for loading assets from all kinds of different formats. I think they have a wiki where they show the different formats that are supported. There's quite a lot of them. In fact, I think they don't even have listed the entire, I have to go always inside the library to find out all of the formats that they support. And it's about 50, more than 50 different formats. Yeah, from Cinema 4D to Blender to STL, FBX, yeah, all the ones that are here, and even more. Yeah, it's like yeah, Quake file format, Half-Life 1 file format. This is mostly targeting games. So yeah, but it's quite thorough. And what ASIMP provides is a way to kind of, they give you a unified model over all these formats. And as I said, this is mostly targeting games, so they expect certain things to be always coming from these formats. So they care about not just the geometry, but the material properties of the objects, like usually people want to define the effects of light on the objects as depending on, so to model kind of the effects of light on the object, you define these three properties, like the diffuse properties of the material, how it kind of, yeah, how it diffuses light depending on the angle of that is incident on the surface. Then you can also model like if the object is emitting light, if it like is generating yeah, light by itself, or if it has like a specular, like a high, like if you have like a shiny surface, you'd want the light that is hitting the object to also, in a non-linear way, have like this shiny hotspot and things like that. And there's like a bunch of different properties that you can read about here that they expose through this kind of common metadata format that essentially you go inside, you just load it, and it's available to the engine. And we now started to port that into Bonsai BonVision. And the way that shows up is the following. So we could try and go back. So I'm going to try and, I had a little scene here. Let's see if here, session 1. So the way you do this would be by doing the following. So we have to create your own resources. You have these like texture resources for images. You have mesh resources for the just geometry, basic geometry. of audio resources for sound. And now you have these new, and so on. And you now have these new scene resources, which is basically a node that allows you to import formats that ASIMP supports. And the way it works is the same as with textures and objects. So you add files to it. You can also drag and drop. For example, there's a scene here that is defined in Blender. So there's a Blender file. You also have support for OBJ files. These are the two that we know work. But if you have others, you can just say all files, and it can just pick whatever you want. And if it works, then if it has nothing, there's many. To be totally fair, like I think there will be many that wouldn't necessarily work as intended, because there's so many kind of parameters and data that these formats bring. Like animations, for example, are not supported at all for now, or like custom effects. Yeah, more fancy custom effects are also not supported. So this is for now is like the basic.
I guess you mean animations in the file.
In the
But
file,
we can
yeah.
create animations.
Yeah, you can create animations. Yes, exactly. Yeah. We will do that in a moment. But again, but just as in, yeah, in many of these softwares, you can define like in the model, like of a character, you could have like an animation of the character moving to pick up something or to kind of point something, and so those animations can often even be stored in the file, and then you can go there and kind of take the timeline of the animations and modulate them or display them. Also, what you have that is also not supported is bones. So this is to articulate for articulated characters. You can also have a lot of different. So instead of moving the object as a whole, like rigidly, you can also move it like limb by limb, or the different parts of the body can be moved independently. And to organize that movement, you have this kind of higher level, what they call a skeleton structure. So that's also usually in the models. So like FBX has that, and a bunch of others have that. Like a Blender also has that, but that will be ignored by Bonsai. So for now, we will get there. But yeah. Okay, so now I guess we could play a bit with, yeah, we can do the Iron Man, I guess, example. So this is a file that we can even look at it in Blender. Or yeah, I guess we could look at it in Blender. I think I have here. I just import the file. So we can import, it's an OBJ file. It's a more complex one. So it's quite a large file. Took a bit to load, but yeah, so it's kind of like this kind of 3D model of Iron Man that is freely available online. And it has like a lot of detail, as we will see in a bit. So yeah, so that loads in Blender like that. And if now I load it inside Bonsai, so you basically point it to the same file. And you have to assign it, because this scene resources, it's kind of general. It's not just for BonVision. You can use it for any, you can even apply your own material effects. So you have to pick which shader you're going to use to process the effects. And actually, depending on how you do this, you could support a lot of the extra properties that I was saying that are not supported right now. But if you know how to write the shader to have them supported, then you could actually already support them, because everything is loaded. It's just the loader looks for whether your shader supports those properties, and if so, it will pass the values of the object to the shader. So it's just in our case, for now, we don't have all of the properties. So for example, if I say, okay, all of my scenes are going to be drawn by the textured model shader, then yeah, so I just pass the scenes are here. This is the Iron Man, so they will be all drawn by that. And then instead of draw textured model, you would use draw scene model. And it's very similar, but now instead of passing a mesh name, you pass a scene name. And so this would be Iron Man triangulate. And then you start it. And we might not see it because it's very close, because the model is actually quite huge. So I need to pull the camera to the side so you can see it. So you can do that by just here. So I'm going to pull the camera way back. And you can also point it a bit up, because the model is a bit up here. Yeah, you can zoom in a bit by this field of view. But so right now there's no there's no texture defined on the object, and the light source is, there's no light on the model. That's why it's kind of all looking very just black. But I can, so let's just put an image here. Actually, I'm going to make it just so it's very, very easy. I'm going to create just a white texture. Yeah, this is all good. Just so we can, I'm going to basically force by way of the texture to have light on the model, just to have it fixed in there. So that will be my texture. So then what I will do is basically go to my textures, add the texture that I just, oops, the image texture. And yeah. And now before I draw it, I'm going to bind the texture to my textured model. That should give me some color. Yeah, which is, now you can see at least some shading. I think, oh, I forgot to bring the materials. That's why it's not, so actually this is a good point. So it's showing, this is black and white because it's just a white, the texture is white, so there's no color on the model. And there's actually one thing that I forgot to do that we will see, but it will be useful to see it first like that. So this here we're just seeing like the surface of the model, kind of close up. So even at this angle, I'm going to add here a, we could rotate the model so you can see it better. So yeah, so there's actually quite a few bits of detail, but what I wanted to show that I forgot to add is this model actually came with a file that is called the material file together with the OBJ file that specifies how each of the little portions of Iron Man are defined. And actually, while I was copy pasting this session state, I forgot to bring that file over. So I only have the OBJ file here, but if I just go here, where my experiments are, so this is this one, the file that is missing is this MTL file. So if I bring this file over, so this file is recognized by the async as part of the, so actually these two files go together. So inside the OBJ file, and actually this will be useful to see, if you open, as I was saying, these formats are very, very easy to understand. So they're actually readable. So if you open the OBJ file, it's just a list of vertices. And you see here at the beginning, it says my material library is that file that I just put in. And then when you are drawing, that it says many, a very big file, but in the middle of the file, I would have to find, I think there's a kind of silver. Yeah, so there's like these directives saying use material silver. And then this will be indices inside the material file that define like the different colors of the different, and the properties of the different materials in the model. Like you have like the red, black, dark, silver, gold, and so on. So these are the things that we didn't have yet because I forgot to copy the file over. But when you load the when you load this with async, it kind of treats both together. So now hopefully if I load it again, so we should see, yeah. So now we see the Iron Man, its full glory. It's kind of so now it's exactly the same model as before. It's just now tinted with the material properties that are defined in there. Yeah, now it's actually very nice to see that there's actually quite a lot of detail in this model, because they don't use textures at all. So they actually, this has like, I think 250,000 triangles or something like that, or vertices. I don't know if it's triangles or vertices, but something like that, on that order of hundreds of thousands of triangles, and they model everything with that. So it's so then you have this kind of very nice infinite resolution almost of the model that you can zoom in quite a lot. Yeah, and so that's the first thing that you gain from using these these new scene support is you get to be able to load these more complicated models that wouldn't be possible before. And treat them as if they're as in one go.
Where's the white texture going? The bind texture tag?
This one?
Yeah.
You mean what it's doing? Yeah. So what it does. So this is a sync. It's marked in purple. So all the purple nodes they have some kind of effect, and they just they pass. So it receives what it receives as an input is not important, in the sense that it all syncs in Bonsai. So all these purple nodes, they will take their input and pass it forward without changing it, but they will create some kind of effect in the background. So in this case, the effect is going to be to bind to the shader model, to this textured model shader. It's going to bind that texture in here. So this is important because it gives you the flexibility of changing which textures are applied. So, for example, you could have different. So okay, let me make.
What happens if you take it out in this model?
If we take it out, then there's no. So you have black basically, because it's basically there's no texture that is bound. So all of the texture data that is used, so all the in this material model that is used, the values in the texture are used as weights to the values in the material. So in essence here, we are multiplying everything by 0, except on those few values that have, so the little highlights that you see, they are specular highlights, where the saturation is like this exponential saturation that it goes so high that it's white anyway, because it's kind of like a singularity. But in any case, actually, I think the specular in the shading model that we have, I think we can actually look at the shader code, but the specular highlight is not dependent on the texture. It's like this, like halo, like this. You can specify the color of the specular light, but it's not weighted by the texture. So that's why we're seeing it show up like that.
So in general, if you have a material file, you should always use a white texture, bind a white texture.
So the files themselves, and this is another thing, this is not the case in this model, as I said, because the model does not use actually textures, although it has texture coordinates, but it doesn't have any texture information. But some models, they can actually have a file. So you can actually have a file. Sometimes when you export these models, you can export 3 things. You can export the OBJ, the MTL file, and the actual image file. And that I think should all be loaded as a whole. But I'm sure if people play around with it a bit, they will find issues and we will kind of improve this experience. But but for now, you should always, I guess, bind the texture to it, even if it's a white texture. You can also create your own textures. So, for example, what we can do is, so this should be possible. If I create the texture here, this is my flat or ambient color. You can also just define a color here that we can say, like, can be any color. You have to give it some size. It can be 1 by 1, I think, but it should have some size. And then you can update the texture here, ambient color. And now if I bind this one, I think, it will work. Yeah, so now we're back to this. But now we could change the color, which I don't know if this will change automatically actually, because I think it might not generate a value when you change it. Not sure. Yeah. So we need to. So now it would change to this kind of. But if we want to update it automatically, you would have to be constantly creating the color on every update frame. And now this will create an image and update the texture contents every frame. So now we can actually go here and change what we want the color to be. Yeah.
Gonzalo, what if you don't want any of the colors, can you just change the opacity? Or what happens if you just change that?
We can change the opacity. You mean the transparency, like of,
yeah,
of
transparent.
it.
Yeah, exactly.
Yeah. So this should be. Let's give it a try. I haven't tried the transparency yet, but so this should accept RGBA textures. So you can actually pass. Let's see what happens. I'm not entirely sure. Let's try. So I've changed it to 4 channels. This thing here, and so now this will be. Well, I can try 0. See what happens. It might. Some things might work. Some things might not. But let's see. Okay, so it didn't well, I'm not sure if it changed or not, actually. Let me try. Because the transparency is used in a different, so let me see. It might change things, maybe not. This one might, yeah, it might not have, yeah, it should have some effect. Because we're multiplying it by, I guess.
It depends on the shader.
Depends on the shader, yeah. It might
Depends
not be.
What you are doing with the alpha channel on the shader.
No, it is being used. The alpha channel is being used, and alpha blending is turned on. So if we go to the BonVision, if we go here to this node, so you can look at the shader state, the way that BonVision sets up the state of the rendering by default is using alpha blending, so it's turned on. And inside the BonVision shaders, if we go, which by the way, if you're curious about it, that we can also customize them. That's another thing that is useful to know. If you go to the BonVision repository, to the actual code, the shaders that are used inside are all here. So you can actually explore them, download them, you can modify them as you want. And you can change. So for example, I'm going to download this. For example, these two. So these are the actual. I think I can just save. I'm going to save this to my. Yeah, I'm going to say this. Let's call them 2. Just you could even have the same name, but it's just for make it more clear. And now we could in here we could do so. Now, in addition to texture resources and scene resources, you can also load your own shader resources. So that means that you could come inside and create a new shader. So I'll call it textured model 2. And then you can load the fragment shader and the vertex shader for how these are actually, what's actually going on in the shader. To use the texture, you also need to bind the variable. So inside these shaders, by the way, so let's have a look at them first of all. So if I open them, these two. So this is the code of the shader. So this is the vertex shader. The only thing that it's doing is receiving the transform that defines where the model and the camera are, and another matrix that defines what's the projection, the perspective transform, or the projective transformation that puts it on the screen. And then you have also the fragment shader that defines how the shading model is actually specified. And this is the important bits are here. So what I was talking about before, that the parameters of the materials bind to pieces of the shader that are defined, and if they are not defined, they are not applied, or if they are defined, they are applied. So they depend on the names over here, and this will be listed in upcoming documentation. But essentially, the asimp defines certain names for the material properties, like color ambient, color diffuse, color specular, shininess. These are all terms that are defined in the asimp. And as long as you have these variables that have the same name, the values of the material will be bound to them. And then this is the equation that defines how ultimately a pixel in that model is colored. And yeah, so here it's a combination of the ambient color, the diffuse color, and the specular color. And there's like different equations that govern how the effect of the light vector hitting on the surface, how it impacts the respective component. So yeah, for the diffuse is like the dot product of the light with the surface. So the more normal to the surface the light is, so you get the intensity of the light proportional to that angle. And then you have for the specular highlights is the similar thing, but now with an exponential applied to it, because it's a nonlinear effect. But yeah, what I was saying about the alphas, as I was saying here, is the color ambient should be multiplied. So the output this is how the texture is sampled. So essentially, it goes into the texture that is mapped to the object, and it reads the value of the texture at the coordinate that is defined in there, and that is read as a vector 4, where the fourth value should be transparency, and that is taken into account. So when, for example, here when I'm multiplying the color ambient by the texel, so this if this had a 0 alpha, then I would expect this to be 0. I guess what is going on is the specular, actually, because the specular doesn't take, this is the one that is killing it. Yeah. So I think because I'm not taking the texture into account for the specular, and so the transparency, the opacity of the texture is being ignored for that. So I would bet that if it's this component, so if I delete it, then I think, or if we just make it a texel alpha, could make it this. If we just do that, then I think it might work. So then if we just what we need to do is then also yeah, as I was saying, so inside the shader, so there's this variable called texture diffuse, which is what will hold the texture that is applied. So to complete the shader definition that I was saying, you have to say that you have a texture bound to that variable. So you have to say here to go to buffer bindings, and you have to add a binding to the variable called texture diffuse. And you can optionally pass it the texture or not, but you can leave it empty, and then bind texture will find it. But essentially, the important thing here is you have to say in the shader what the name of this variable is in the shader declaration, because the program doesn't know. And you can have different textures. You can have many of these textures applied for different effects, so it can get quite complicated. So anyway, we're doing all this by hand now. That's why it's getting like that. But maybe if this works, so now we could say that might have to do this. I'm not sure. Oh, maybe not actually. Let's try it. Try it like this. If this is clever, it should not blow up. But now I want to use my texture model 2. So texture model 2 that is declared here. But when the resources are loaded, they should be loaded in the order of their dependency. So it shouldn't matter the order that you define it. But let's see. So now I'm using texture model 2. The scene is that. This is now going to texture model 2. Yeah. Let's see. Oh, there's nothing. So maybe it worked, maybe it didn't. I don't know. Let's change the opacity here to 128. Ah, it did something. Oh, there you go. So now it's yeah, it's doing like this very kind of, yeah. So now you can see like even the some of the triangles are clearly not drawn, not sorted to. So if you want to draw transparent objects, then there's like actually a lot of different things that can go wrong, in the sense that the way that the model is prepared needs to take into account the transparency. So the triangles need to be sorted in such a way that anyway,
back culling.
Yeah, there's back culling, and then there's sorting of the triangles themselves. So the order in which the triangles in the object are drawn should be to have a correct transparency from the front. It should be sorted from back to front. Otherwise, the triangles are being blended with the background, and if it can be, so many of the effects that are here, I would suspect, are because we are not sorting the triangles, and we are probably drawing them by whatever order they came in the file. And so, anyway, this is for another conversation, because transparency is actually.
Actually, in the interest of time, we've got like 15 minutes
exactly.
left. Maybe we can move to like the scene with moving objects in a scene kind of that one.
Yeah, we can try to do that. So yeah, this one is just one object. You can just draw it like that. Let's try to use another scene that I have here, which is this one, scene blend. So this one has more objects in it, and also has a camera that is part of the scene that you can render. And one thing that is nice, so when you load these kind of scene formats, so some of formats like Blender, if they have a camera, then or lights, for example. By the way, this also has a light in here, but these objects are also loaded as part of the scene in the scene resources, and you can use them. So you can use them to draw the scene, to draw the object from a certain viewpoint, or you can also take the independent objects. So in this case, we have more than one object, these different scene nodes. So these are if you look here on the right-hand side where I have my mouse, there's like a hierarchy of the objects in the scene. And these you can also control individually. You have access to the scene hierarchy inside Bonsai, that you can also pass transforms to independently. So one thing we can do, for example, we can. So I'm going to load that scene first of all. So scene blend. So you can also just drag and drop it in there. And now what we can do, so in here, we were actually using we were defining the perspective view. So the camera, we were defining it in BonVision, but we can also use the camera that is defined in the file. For now, this is actually not exposed yet on the BonVision node. It is exposed on the Bonsai node, but we can actually modify it. So you can go inside. I'm going to open up this group, so ungroup, and I'm going to actually in here. So this is what's inside, the different transformations that are being composed. And in here, there's a property that I didn't expose, but I will now, which has the camera name. So this is you can pick which. So I can pull it out. So now you'll be able to specify on the scene model what camera you want to draw the scene from the perspective of. So in this case, the camera, I think it's called camera. It's just camera, yeah. Let's call it camera. And if I look at the scene, don't know if this is going to work right away. But let's see. Vertical gratings. Texture resource with the name vertical gratings was not found. it's trying to draw something.
I guess we don't need the texture resources right now, right?
I think it says related to that, yes. Actually, I'm trying to think where it's trying to get. It's trying to get that from somewhere. Not entirely clear to me where it is, but let's draw it also with not with the tech. Let's draw it with the. Let's try to draw it with the texture with a normal textured model. If that doesn't work, then we can also try. Actually, we need this. No, we don't need this. Yeah, we don't need this. This should be just normal textured model. Let's see if this works. If it doesn't work, we can also just try to. I have another workflow here. It's a backup. It's looking for a texture that is not defined, which is probably actually, it might be a missing file, I'm realizing. Because I was actually, yeah, this vertebrate JPEG. Because I think I was playing with the model, I think. And oh yeah, because I was applying, I know what it is. Yeah, I was applying it to, yeah, I should bring this over. I was playing with these models because you can also, this is part of what I was saying. You can apply textures to the file inside Blender. So you can say, so if I go inside Blender, actually, this is what I was not showing. So if I actually inside Blender, if I show this as a, I think maybe yeah, the texture views. This is not it didn't find it, but if I load it again, I think it might. So if I draw it as a texture, yeah, so now it was painted with a kind of a, it's kind of like a gratings, like a sign gratings view. So I think you need to use it as a material, yeah, like that. Yeah, so that's the, so I was applying this, so this texture was the vertical gratings actually, this one. So actually the complaint was within the model. So the model was trying to load this file and wasn't finding it. Okay, so now it should actually be there, I think. Let's see. I might have to declare it. Not entirely sure. It's also good as a vertgrat. Yeah, I think I have to just, you have to declare it here, the files that are auxiliary. We might just load them later as part of the loading procedure of the scene, but for now. Yeah, there we go. So we have the essentially the model. So we have it drawn from the point of view of the file that went into the that is in Blender defined here. Actually, it's funny because I realized Blender itself. Yeah, this is more close to what we are seeing. The light is off. Because we actually have to move the light, but it's essentially what I wanted to show is, so this file kind of draws the everything from the perspective. You should get, the nice thing is you could define like your scenes and also the perspective into your scenes inside Blender, and it should match exactly to the, this is just the same. So you're kind of matching the, you're getting the same view of the scene as you have inside the Blender. And you could change it. So for example, if I now go to Blender and I change where the camera is. So if I make it, let's say, closer. Okay. So now I'm seeing it a bit more, oops, a bit more. So now it's, yeah, like that. So now I have this kind of close-up of that little part. And if I save the scene and I play it again in Bonsai, so you get that same close-up. So it's so the nice thing here is you can have these, you can not just define your scenes in Blender, but also define your viewpoints like as cameras in the scene, and you could switch between them. So for example, I have another camera there that is the this camera 001, which is somewhere inside, is like there. which probably we're not going to see much. I think it's not seeing anything at all. So I don't know where it is. Here, that's unclear. But if we save that, if we reload it, you can actually pick that camera inside. So if I now change this to, so we have the camera here to camera.001. So that should now be drawing it from the perspective of that camera, which now is probably pointing nowhere, which I can probably fix by having it just zooming out. So what I can do is probably just, so here, oh, so just zoom out a lot, pull out a lot. Hopefully it's pointing in some direction. Should see something. Oh, what did I do? Oh, I typed in something here. Camera.001. Yeah, so now we're seeing it like pulled out, and you could switch between them so real time. So you could kind of go from this to now my camera, and now you switch between them. So you can kind of go between, you can have like different views on the scene and kind of yeah, jump between them or teleport to different parts. So if this is like an experiment with like an animal moving through a corridor, then you could kind of teleport. There's multiple ways to do. You could have like multiple corridors lined up. The camera could be moving, and then you could either teleport the maze or teleport the camera to another camera, or just move the camera to another section of the maze and so on. But this makes it easier to define, well, just more tools to define what you can do. But
and can we move an object within the scene?
yeah, so that would be inside here. We have to go again inside. These parts I need to kind of expose them to the BonVision, but we can actually, so here, the same way that you define the view matrix, you can update the transform of an object. And actually what you can do, we can actually, I'll do that outside here, just so we can, so I will do the following. Let's define what's the easiest way? Let me move my mouse, take the, yeah, normalize. This will be good enough as a angle. And I'm going to create a rotation around the around the y-axis, I guess, and map my mouse to that rotation, to the angle. So that number, yeah, that number will be mapped to the angle of the rotation. And then this, so well, you could do it inside here as well, but one thing that is nice is you can also do it outside. So you can, from here, you can say, okay, I want to update the transform of my scene, which is my scene, and then you pick a scene node, like a node name here. And this node name would be a name that is defined in the, so in this case, let's say Suzanne would be, or the cube would be, these would be the names that you would put in. So you could, here, let's say the cube. And I have no idea if this is going to work, but we'll find out. Yeah, so now I'm kind of moving on the y-axis. So I'm moving just that object, so kind of independently. And you could do the same with so you could say that y moves the cube and x moves Suzanne. So you could just do that. So you would have a kind of a, oh, they're both, oh, I've transformed them. Oh, I cheated. So I didn't take, it's a good point. So I forced the transformation onto it. So I just put them both at 0, 0. If you don't want to do that, then you have to get the transformation from the scene, which you can also, I think you can also do that on the, you have to say scene transform, I think here. Yeah, so the scene transform gets you the transform matrix of the scene nodes. You can also read it. So update transform will set the transform, and scene transform will read the transform. So you can also say, okay, I want to take the Suzanne's transform, and instead of just forcing it, so in Bonsai you can either create an absolute rotation, or you can rotate. So these two are kind of like two sides of this different coin. So in create rotation Y, you create an entire transformation with that is at 0, 0, just rotating in Y. If you rotate that, so this is you're composing it. So you take a previous transformation and you now apply a rotation on top of that. So what we want to do now is we want to take the scene transform of Suzanne and rotate it by a certain value, or we can also just do. I guess we could also just multiply. So we can also just do the following. We could do take the latest transformation and multiply them. It should work. If we just take, yeah, the scene transform of Suzanne. I don't know if the order is correct, but we'll just find out. Yeah, so now it's correct. So now I'm moving Suzanne like this and the cube like that. Yeah, so this was just a matter of composing transformation. So I had to take the original transform of Suzanne and apply the rotation on top of that original transform so I don't move her. Because I guess what I did before is if this is not here, then I'm actually just setting the entire transformation. So Suzanne gets transported to the 0, 0, because this is a full transform. So there's no translation information. So when I say update transform, it's actually just setting the entire transform. So yeah. Anyway, there's more ideas to come on how to do these things, but for now, this is what you could do.
So I guess in terms of just getting like the scene information, it's like scene transform and update transform. What are they under? Which toolbox are they under?
They're under rendering. So it's these are all the things you can currently do. So there are shaders rendering, and you have so scene transform reads the transform of one of the scene component or the entire scene. So if you don't say anything, it actually reads the transform of the entire scene. If you say a node, it gives you the transform of that node. And update transform, you can also update the transform of just one scene or the entire scene. So, and then you can update these are more like low level, because in this case, BonVision, we were using BonVision to kind of give us this, but if you wanted to do it more low level, you can also specify where the view matrix, where the viewpoint of rendering the scene, where it comes from, and also the projection matrix. And then you have, scene resources that we were using to load the scene, and draw scene that we were using to draw the scene. Although in this case, we're actually using draw scene model, which is a BonVision node that kind of makes it integrate seamlessly with the other views, with basically the other nodes that are in BonVision. Like if you wanted to render things from a cube map or from a head-mounted display, then you could just, by using this draw scene model, it would take care of like rendering the multi-views like automatically for you. So yeah, so I would say for integrating this into BonVision, it's better to use the draw scene model node that comes with BonVision. Not this one is more like the low level. This one would the shaders rendering draw scene would be, you have to set up everything yourself, like the view matrices and everything. Whereas in here you can just pass it as an input. So yeah.
Two questions. One, I guess, is quite straightforward. Will you be able to move the camera, which was imported for Blender as well, as a result of, say, moving a mouse?
Yes. So the one cool thing is we can actually try that actually. So the camera itself has a node. So if we say draw the scene from the point of view of that camera, if we now update not Suzanne, but this should work actually. So camera 001 is also a node. So if I say I want to move camera 001, so let's see what it does. But so now we're actually moving. Oh, I need to, okay, I need to also update here camera 001. Otherwise, I was in the middle of the objects in 00 together with them. It's the same thing, but now, so now I'm moving the camera. So the same thing as before, but I'm moving the camera instead of the objects.
Cool. That leads on to very well onto the next question. Is
Okay.
Do you think you'd be able or could you have, because you can have several cameras, can you have those projected to different screens?
Oh yeah,
So that you can in effect have two animals interacting, so in two different head-mounted environments, having each their own screen, but they can actually interact with each other. If they update each an object and a view, can you couple an object with a viewpoint?
You can, so there's many ways to do that. I can show you very quickly two of them, because we do have two cameras actually here. So we can, so for example, here I can take, so when you draw a scene in BonVision, this is also, by the way, how we handle multi-displays, that I guess we will talk about it in a future session in more detail. But just as a quick example, one thing you can do is you have this draw viewport node that essentially you can control where the scene you are rendering, or the view you are rendering now, where it's where is it copied onto the screen, in the screen. So this is a very we have more sophisticated steps in BonVision, but this is at the very last step. Is you say, usually when you have multi-displays, you want to have like a single window that kind of spans across all the displays. And then you control actually the contents of each screen by the viewport. So for example, here I can say, okay, instead of drawing on the full window, I want to draw only on the left side of the screen. So the width of this is in normalized coordinates from 0 to 1. So in this case, if I do this, then effectively my scene is only drawn on this kind of left half, okay? And then what I could do is I could take I think this will work even like this with a copy. So if I make a copy of this and, oops, sorry. If I'm going to put them side by side. So I'm going to render now like a copy of the pipeline. But now here I'm going to use camera rather than camera 001 and draw the viewport to, so now I have to give an offset to 0.5. So it's shifted to the right. And I don't know if it's going to work, but yeah, so now you have like the two scenes kind of independently, because that one is painting the same scene. And actually we could show this by, if we now go back to Suzanne, okay, and we do Suzanne like that. So now we should be moving it to, so now we're moving Suzanne on both, right? So the scene is moving, but you have the two views on two different parts. So then this would blow up to like across your displays, and yeah, one would be one half and the other would be another half. Is that cool?
Cool.
Yeah. So yeah, maybe I don't know, maybe we leave it at that. I don't know if there's more questions, but
I can stop recording and then we can keep.
Yeah, I'll put these files anyway. I guess I don't know if we sent the last files, but we can send these ones as well, so they're available for people to play. Yeah.
Anyway, thanks for that, Gonzalo. I'll stop recording now.
Yeah.